the natural exponential. So the natural exponential function is the exponential function written in the form f y equals e to the power of x, where e is a very special value of the base, which is given approximately by this number 2.7182828459045, etc., etc. E, the number itself, is irrational. It's not a fraction. It does this decimal expansion of the number doesn't recur. It doesn't repeat itself. It's always it looks like random, of course, and therefore this number is irrational. So what is the why did we choose the number e in such a way? So this is exactly what's written in this mind map, the definition, what this exponential function is, and why would one pick out such a strange value for the base. And here we have the answer. The value e is the only base of the exponential function for which the tangent of the function at the point 0, 1 of its graph has the gradient equal to 1. So before I continue, let me try to review this concept of gradient. Imagine I draw a line like this one. Okay, this line, as you move a point along this line, you see that always as it moves 2 units to the right, at the same time it has to move 1 unit in the vertical direction to stay on the line. So if I move from this position to this one, this is represented by 2 translations, translation to the right by 2 units and translation upwards by 1 unit. So if I take this which is the y step, and this which is the x step, and if I divide these two, what I get is the gradient. So it's the y step divided by the x step. So this is just to review this concept of gradient. So what is the gradient of this line? The gradient of this line is 1 divided by 2. So the gradient of this particular line is 1/2. Okay? Now, what does it mean that the gradient of the line has to be equal to 1? If the gradient is to be 1, it means that the line has to go in this particular direction, and it means that as you move the point along this line, every time you move 1 unit to the right, you have to translate 1 unit upwards. So the y step is going to be 1, and the horizontal step, the x step, is going to be 1. And if you try to calculate the gradient of this diagonal line, what you get is 1 divided by 1, which is 1. So what we want for this exponential function to be true is that it has the gradient of 1 at the point of 0 and 1 through which it passes. So let me look at this in GeoGebra. So here we have the model of the function of the exponential functions, and the slider here allows me to change the value of the base. So this, and in this particular case, the base is 2 and the exponential function is 2 to the power of x. And here I have this point which I have called t, and this point t has the coordinates of 0 and 1, and what I want is the following. I want that the tangent in this point, the tangent to the function constructed in this point, should have the proper gradient of 1. So if I allow this model to show me the tangent of the function, okay, in the point t, what I can notice is the following. For sure it doesn't have the gradient of 1, because if it did, it would go through this point and then through the point with coordinates 1 and 2, because it would move 1 unit to the right and 1 unit upwards in the vertical direction, and it doesn't. The gradient of this line is a little bit less than 1. Okay, so if I change the base of the exponential function, also the tangent changes, and what I can try is to find exactly such a base which results in the tangent passing through this point with coordinates 1 and 2. Okay? To do it precisely, what I can do is to construct the vertical passing through 1 at the x-axis, and I can construct the intersection of the vertical line and the tangent itself, and let this model let it show me the coordinates of this point. And if I do that, I can see that the vertical coordinate of this intersection point of tangent and the vertical line at 1, it changes. Now it's 1.906. What I want, if the tangent here has to have the gradient of 1, what I want is that this point has the coordinates of 1 and 2. So let me now increase the base A, and let me look at the vertical coordinate of this point and try to fix it so that the value of this intersection is exactly correct. And now here it is. Yes, you see, when I take the value of the base equal to 2.718 and so on, which is actually the number E mentioned a minute or 5 minutes ago, I don't know, then the gradient of the tangent is exactly 1. Okay? If the base is greater than this number, the gradient is going to be more than 1. If the base is less than this number, 2.7 and so on, the gradient of the tangent is less than 1. Okay, so the proper value of this is 2.7. Okay, let me set it better. I have to move back, and you see it takes many steps because I'm changing it very slowly, and this is the proper value, 2.7182, approximately to 4 decimal places. Okay, so this is the definition of what E is. E is such a value of the base of the exponential function which has the proper gradient of the tangent at 0 and 1, and this gradient has to be 1. Okay? Now, you may ask, where is the natural exponential used? Well, this question, when some time passes, and if you will have completed your studies at the university and having completed calculus, for example, this question will seem ridiculous to you, because in calculus the number E is very much present in all the calculations which require making integrals or derivatives of functions and so on. So E is ever present in calculus, which is part of mathematics, describing changing quantities, and therefore since it describes quantities which change in time and they change irregularly, then it means that it's also going to be used as a modeling tool in science. So in physics, for example, you can encounter E in for example, the radioactive decay. If you have the number of atoms or nuclei which have not decayed yet, then the formula given for this number is the following. It's like this, and the lambda is a constant at which it's the constant rate at which the radioactive decay occurs. So the law describing this decay is the following. It should be the following. Okay, so if some of you get to these details, you will then find this knowledge useful, the knowledge about the natural base of the logarithms. If you don't understand these two formulae, no problem, just ignore them. Now, E is used also in engineering and in finance particularly when we do the continuous compound interests at the investments. Okay, so that's it for this video. Thanks for watching.